Hello and good evening. Today we're going to, in this particular section, I would like to demonstrate how to test a RT series overload relay that some of GE's customers use worldwide. What I have in my hand is a RT12M is the model, as you can see, but it doesn't matter whether it is an RT12 or a RT222 or an RT32 or any other model that we supply to various customers. The testing procedure will be the same and the functionality will also be the same. The objective of this exercise is I would like to demonstrate how to verify an RT series overload relay without applying any voltage or any current going through this device. We are going to check the mechanical integrity as well as the electrical functionality. Basically, we're going to verify the continuity between the auxiliary terminals, as you guys can see over here. So those things I will explain in a step-by-step. I try to simplify as much as I can, but it is not really a big deal to test this one. In this testing, I'm just going to use a very simple multimeter, which is a Fluke 87.5 is what I have. So we can use either use a Fluke 87.5 true RMS meter, either equivalent to this one or any better multimeter, because every multimeter, as you guys can see, you have a voltage function, measurement function, whether it is AC voltage or DC voltage or millivolts. And then as you can see here, when you put it in this mode, you can see that symbol, ohmic symbol, as you can see over there. If I try to use a buzzer mode, then you can actually select a buzzer mode if you want it. Or if you just want to measure the resistance, you can also measure the resistance. So I'm pretty sure that most of you guys have already used a multimeter, so I don't want to really go too much in-depth detail how to use a multimeter. The whole objective of this exercise is to verify how to verify the mechanical functionality, mechanical integrity, not the functionality. We are not going to check any mechanical functionality. We're just going to check the mechanical integrity, because as one of our customer, a potential customer, is experiencing some quality issues, we are trying to do this exercise of, say, so-called filtration, incoming material filtration at various stages to just understand and see if the product is being affected during transportation or maybe during manufacturing, or it could be a design related. So we are trying to establish a root cause to see whether the mechanical functionality is failing and doesn't meet the customer's requirement, as well as we have some issue with the auxiliary contacts. As you can see on the front, this particular relay or this model, or whether it is a class 20 or a class 30 or a class 10, they all got only one normally open contact, which is, as you can see in this, not sure if you can see, but 95 and 96 is a normally closed contact, and then 97 and 98 is a normally open contact. That means in an ideal condition, when the load is not overloaded or this device is not tripped, these contacts are supposed to be normally closed and the other set of contacts are supposed to be normally open. So let me start first with the mechanical integrity. As you can see, these three prongs are attached to the top. There is a contactor device where the voltage is coming through the contactor and it applies through this overload relay. And as you can see on the bottom, there are some power terminals. From the power terminals, it actually goes towards a motor. Motor is connected. So in the event, if the motor gets increases, there's an increase in current of the motor, be it because of a mechanical jam or a malfunction, something, an issue with the winding in the motor. In those kinds of situations, what this overload relay does is it senses the current and converts that into some sort of a temperature, because all these overload relays internally, they have a bimetallic strip. At a certain temperature, they will somehow, inside there are some functions. What that function does is it tries to activate the normally closed contact, which was closed at one time. Now, because the motor is overloaded for whatever reason, whether it is a mechanical jam or maybe something else that has happened, caused this overload relay to trip. So at that point of time when it trips, the normally closed changes to a normally open, and the normally open contacts will go into a normally closed contacts, normally closed connectivity, or otherwise you can call it as, this is in ideal condition, it is a short circuit, but when the relay is stripped, it becomes an open circuit. Vice versa, the 97 and 98, in an ideal condition, it's an open circuit, but when the relay has stripped, it becomes a short circuit. Now, let us try to see the mechanical integrity, what I'm talking about over here. As you can see, these three prongs that are there, and this hook, I'm not sure if you guys can see, this hook actually attaches to the contactor to give a firm support. The issue that we've been seeing is from this is the cover of the overload relay, top cover, as you can see, and on the bottom is called the housing, and inside is where all the mechanical moving devices, moving components, and all these plastic components, all the construction is inside the housing. This is just a cover, but this cover today, one of our customer complains that the cover is loose, or otherwise on the edge, as you can see, it sounds to be pretty open, or maybe you can see a fine little opening over there, which is not considered to be an acceptance. So that's the issue what we have on the mechanical integrity. So how do you verify? I mean, in this particular relay, I see that all the four corners seems to be well sealed, and how they are sealed is, as you can see where my finger is at, there are some hooks which actually passes through this hole and holds this top cover intact. So there's two holes over there, and then on this corner there is another hole. So there is another hook. Similarly, under this sticker, the black sticker on this side, as you can see, there is another hook too that supports to it. And one more, if I peel this sticker off, you can see right over here is another hook. So all these hooks basically try to support this guy to keep it firm and intact. So how do I verify that it is mechanically strong? It's nothing but a human judgment. When you look at the relay, I don't see any openings over here on the top cover where these three prongs are at. And now I try to tug it by holding this hook that I got. I can just pull it to just make sure that there is no opening, or I don't see anything up over here. You can use some kind of a judgmental force. Don't try to really yank it so hard that it comes out. But as long as you don't see any kind of an openings, as it is when you take it off from the box, by the way. Okay, when you take it off the box, you should not see any kind of a gap up over here on the four corners. I'm not sure, guys, if you can see where my nail, I'm trying to insert my nail over here. Okay, there is some small opening. Okay, but I'm not going to really damage this equipment, and maybe it is what it is. I won't consider this to be a bad part, by the way. There is some opening, but we're trying to figure it out if there is a way that we can seal it all the way so everything is going to be well supported. So don't get confused when you do the mechanical integrity. If you see a fine little opening, that's okay. That's a very normal thing. But if you see like something that is really drastically open, like I was telling you, when I hold this hook and try to pull it, if you feel that the cover is coming out, then you consider this as a non-compliance component. I hope I explained this very well. Nothing much onto it. Just look at it and make your own judgment to make sure that the four corners are pretty sealed. Okay, and then if everything looks good, write down the serial number of this relay, document it always. The model number and the serial number is what is important, because that's what gives me the date code. Is a very important thing, because once the product leaves from the Mount Juliet warehouse to the end user, in this particular case, it goes to a customer called Danfoss. They're located in Milwaukee. So Danfoss is a big drives company. We buy drives from them. They also buy overload relays and lots of other components like contactor, enclosure, starters, and all kinds of stuff they buy from us. So it's a very important customer. The impact to our business is they do a business of about $2 million approximately a year. So it's a huge potential opportunity for GE, and we wanted to make sure that our objective is to keep Danfoss happy, and they keep the customer happy. That is what I can tell about the mechanical integrity. In case if you guys have any questions, shoot me an email, or you can reach me on my cell 704-961-2055. Okay, and let's look about the electrical functionality over here. As you guys are already aware of it, the first and foremost thing I suggest you guys look and see where this yellow dial, this is where my finger is, the big round circle, that is called the selector mode. As you can see, I'm sorry, not the yellow one. You start with the red one. This is wrong. I apologize for that. You take the red, which is called the reset button. This is always where we start with. The reset button has an arrow indicator, and this arrow indicator should be pointing out to something called M-O. That means manual off. So make sure that the arrow is pointing towards MO. There are other ways of doing too. Other numbers are there over here, or characters are there. Like for example, you can use manual mode, or manual off mode, or auto off mode, or purely auto mode. You can see these guys up over here, these characters, you can see it. All I wanted you guys to make sure that the arrow is pointing towards manual and off. That's the number one thing. Don't worry about the big yellow dot. Just leave it wherever the settings are at. We're not going to get worried about it. So the next thing is, in this particular situation, before you do the electrical functional check, like I said with the multimeter, a Fluke 87.5 or anything equivalent to it, or better than this one, it's okay. So try to put the multimeter in a continuity mode. As you can see this little ohmic symbol or a buzzer symbol that is there. And if I take my multimeter and try to touch both the leads, you guys should be able to hear a noise. That means we have a continuity or a closed circuit, right? That's a closed circuit. So when you see a closed circuit, you will be seeing like this. I would suggest instead of using the buzzer, there's another way. You turn the buzzer off. Now, when you short these two leads of the multimeter, basically you see a very low resistance, something like 0.2, 0.3 ohms. Because there's not much impedance over there, you see a very low ohmic value, and it's under a short circuit. That means because my leads are all both touching together, so this is very normal. Now, when I take them apart, you can see an open circuit. We should say that OL means it's nothing but an open circuit. So let's grab the RT series overload relay. And what I'm going to do is, first thing, in an ideal condition. Now, right now, nothing has tripped. And I forgot to mention you guys, there is a small yellow little tab, okay? That is called the test tab. That means I can take, in my case, because I don't have another tool, I can use this guy. When I push that little yellow thing, it will basically trip it. And as if a motor is connected to this one, and it trips. So when it trips, like I told you before, the 95, 96, it changes from normally closed state to a normally open, and the 97, 98 from a normally open, it goes back to a normally closed condition. So if I take my multimeter, I'm going to take my multimeter and come here, Sarah, for a minute. Can you hold this for me so I can demonstrate this one? Thank you, sir. So multimeter is still now in the ohmic mode. Okay, and what I'll do is, because you guys can hear the noise, I'm going to turn it the buzzer mode and verify 95, 96 first of all. So as you can see, 95 and 96, I don't want to go on the top of the screw, guys. Go on the bottom, because you don't take a screwdriver and you don't tighten it up, you may get a wrong reading. Always go underneath the bottom of it and try to put the leads of the multimeter on it, and then you should be hearing a buzzing noise. And if you want to turn the buzzing noise off, you can, and you still see a very low ohmic value, something like 0.6 ohms or 0.7 ohms, something like that. Okay, now let's verify the same thing for 97, 98. Like I mentioned before, it's a normally open contact, so you should not see. Oh, by the way, this is interesting. The normally open contact, according to my meter, is showing that it is actually close. It sounds to be interesting. Let me make sure that I reset this, because this is actually a faulty device, guys, and I bought it borrowed from the customer when I was coming back from Milwaukee. So But let's verify again. 97 and 98. Okay, it was my mistake. It was already tripped, so it doesn't make any sense. Okay, let me. Okay, all right. So the normally close contact, as you guys can see on the multimeter, is reading about 0.3, 0.2 ohms. Now I go to the 97, 98 and I measure it, and as you can see, it's an open circuit, right? So you can see an overload. Now, as you can see, I'll take one of the lead of my multimeter and try to use the push test button and trip this guy. Okay, now I take the multimeter. Remember guys, again, don't go on the top of the screws. Sometimes if the screws are not tight, like you see these two screws, because I'm not using any screwdriver, we can get kind of get a false reading. So go on the bottom, as like you can see over here. And now you see on my multimeter now, it is showing an open circuit, right? Because the relay is tripped. So now let's go back to 97 and 98 and re-verify. That should be a short circuit, right? So, okay, as you can see, it's shorted. And as you can see on my multimeter, it is now showing a shorted signal. So 97, 98 now is showing a short circuit, and 95, 96 is showing as an open circuit. Now what I'll do is I'll try to reset, use the red push button, try to reset it, and let's re-verify to make sure that it goes back to its home state, which is 95, 96 should be closed. Yes, it is. And then 97, 98 should be open. Okay. Maybe I didn't reset it properly. Let's verify, make sure that. Okay. As you can see on the multimeter now, it's open. All right. So just make sure that when you guys do it, use the reset button firmly to make sure that it is resetted properly, and then verify it. Okay. I mean, it's a pretty straightforward. Like all I want you guys to do, the electrical functionality check is 95, 96. Verify the continuity in an ideal condition. That means, remember, then the relay is not tripped. And with the multimeter, it should give you a shorted signal when I verify this one. And 97, 98 should be an open circuit. Okay. I'm not sure why this guy occasionally it keeps giving me, yeah, say for some reason, like right now it's showing me overload. Like I said, that this is probably a bad relay because it has been over torqued when we were in Milwaukee. Maybe something internally could have been damaged, but it's that's what I wanted to explain. Is these are the two things that I want you guys to verify: the mechanical integrity and verify the 95, 96 with the multimeter. In an ideal conditions, it should be close contact, and 97, 98 should be an open contact. Okay, and when I use this one and use the test button to trip it, as you can see, it tripped. 95, 96, when I measure with my multimeter, it should be open, and 97, 98 should be shorted. That's what I want you guys to do it. And at the end, make sure that the reset button is firmly pressed a couple of times, and then re-verify with your multimeter to make sure that 95, 96 goes back to a short circuit condition, and 97, 98 should go back to an open circuit condition. That's all I wanted to say. I hope you enjoyed this short video. But if you have any questions or anything, feel free to reach me out on my cell number 704-961-2055. Thank you for joining, and I appreciate it. If you have any questions, feel free to reach me.
Let me see.